So I'm back today to show you the real easy way to remember the density, mass, volume variables and how to manipulate those variables into their different proportions. First thing I'm going to do is I'm going to start out with a triangle. I'm going to divide it into thirds. Bottom left, density. Top, mass. Bottom right, volume. So here's how we manipulate this to get your proportions. If I'm looking for density equals mass over volume, if I just cover up the density, my mass is on top and my volume is on the bottom. That's how I get my fraction. Mass over volume, mass over volume. So if I have a mass of 97.2 grams divided by 112.6 cubic centimeters. Take that, remember your rounding rules. Divided by 112.6. That turns out to be 0.8632326. We want to get it to one decimal place. So we look at the second spot. The second spot's called the hundredths. That 6 is between 5 and 9. So you're going to make that 8 into a 9. So that's going to be 0.9. My numerator unit goes first. My denominator unit goes second. What if I'm looking for mass? I'm going to cover up the mass. Mass equals density times volume. In math, when numbers are next to each other, you multiply them. Density times the volume. So if I take density of 4.6 grams per cubic centimeter, and then multiply that by the volume, 1.4 cubic centimeters, I'd take those numbers and multiply them. 4.6 times 1.4, and that's going to come out to be 6.44. You take the 4 in the hundredths place, it will not change the 4 in the tenths. So 6.4, the cubic centimeters cancel out, the mass unit is going to be grams. The last variable that we want to find is volume. So if I take my little rock there, cover it up, now it's going to be mass divided by density. Mass divided by density, mass in the numerator, density in the denominator. Mass, let's say in this case, is going to be 17.4 grams divided by the density of 4.1 grams per cubic centimeter. Take those, just divide them. Mass of 17.4 divided by the density of 4.1, and that turns out to be 4.24 with the remaining numbers. Rounding rules, the 4 in the hundredths will have no impact on the 2 in the tenths. 4.2, the grams cancel out, cubic centimeters. Okay, remember, you can also use milliliters as well. Those are interchangeable. Remember, there's other ways that you can determine you can determine volume as well. Length times width times height. That will be for a regular sided object like a cube. Or you could do water displacement. So those are going to be two other ways you could get volume outside of using the formula. So hopefully this kind of gives you a little bit of a clue about how to determine the variables for density, mass, volume, and how to interact those values to get your calculations. Talk to everyone soon.